All right, cellular phones and life expectancy. A survey of the world's nations in 2004, a while ago, shows a strong positive correlation between percentage of the country using cell phones and life expectancy in years at birth. Does this mean that cell phones are good for your health? In 2004? To think back, this is like the year y'all were born, right? Garrett, you were like, what, 1, maybe 2 years old? 2 years old? I was a nice 7 years old at the time. Yeah, they would have been like flip phones, so probably a little less likely to save your life than the phones we have now. So based on this, would we say that cell phones are good for your health? Okay, ignore question B. We don't know anything about B yet. Just question A. Does this mean that cell phones are good for your health? Just because life expectancy is higher. So it's good to have a cell phone. Basically is what we're saying. No. Okay? What this means is that countries with a higher percentage of cell phone use also tend to have higher life expectancy. Why might that be true? And typically in poor countries, what is the life expectancy? Super low, way shorter. Okay? So that does not imply, okay, this is one of those things that correlation doesn't mean causation. Okay? Wealth of a country impacts percent of cell phone usage and life expectancy. Okay, wealth could be a lurking variable. Okay, which is a variable that impacts both variables without us taking it into account. Okay, so we didn't necessarily take it into account specifically about cell phones and life expectancy, but it's one of those things that obviously would play a part in it, basically. All right. Lurking. My R's and stuff kind of run together with things. All right, conditions to check before doing a linear regression. Variables must be quantitative. Variables must be quantitative. Okay, they need to be measuring something. Scatterplot must be linear. Okay, meaning a straight line. Okay, relatively straight. Lastly, Outliers. We want to give correlation without outliers. Or with and without, with and without outliers. So we want to see what happens with that. They also, who was it? They did play a match on Tuesday. I just remember who it was, but it wasn't, yeah. We still did better than the team that they did, and it's one of the teams we play next week. I just can't remember who. I think it's probably Portsmouth. We almost took a set from them. 8-25. They also got a new gym. Their floor is completely new. Their bleachers are gone. I'm assuming they're going to put them back in, but they were like playing that space for volleyball. So I'm guessing after they did their floor, they just never put them back in. Oh, this one doesn't. This one's nice. Kind of want a floor like that. All right. Roller coasters. This might be the last two here we do it at the bottom. Roller coasters get all their speed by dropping down a steep initial incline, so it makes sense that the height of the drop might be related to the speed of the coaster. Here's a scatter plot of the top speed and largest drop for 75 roller coasters around the world. Okay. Does the scatter plot indicate that it is appropriate to calculate the correlation? Does it follow those three things? Are the variables quantitative? Okay, both variables are quantitative. Okay, is the scatter plot linear? Okay, relatively linear. More or less in a straight line. It's not like curving or anything. How about outliers? Possibly, but probably not. They're all pretty close together, so probably no outliers. Based on that, is it appropriate to have to calculate a correlation? Yes, we can calculate correlation. You could have used that. The implication was you can use anything we've done in class. Alright. In fact, the correlation of the speed and drop is 0.91. Describe its association. So that basically just we can see is R is approximately 0.91. Strong. So I want to talk about the shape, direction, and strength. So positive, strong, linear relationship. Between initial drop, and the speed of the coaster. Coasters with larger initial drop tend to have faster speed. Is it? Oops. Yeah, already done. I thought when I typed it they were two different problems. That's why I didn't even think about it. So, oops. Now let's go ahead and see if we can work on the next one. Start it. I was going to say, do you have to leave right at? Okay. She's just supposed to get here around then. How close is she? Okay, we got time to do this problem then. I think sure we had time to do the problem, because if not, I was going to go pick a different one. Alright, so, the thing to note here, okay, percent who have used it, and percent who have used it, and then percent who have used other, okay? These are all, both of these are L1, both of these are L2. Okay, so make sure you pay attention to that here when you're going and inputting in the data. And we're going to hope my calculator works because I still haven't gotten batteries and I really need to put that on my to-do list. And the other day it was not working, so. To do the scatter plot? Yeah, and you'll need to clear your y equals if there's anything graphed in there. Just plot one. No, they'll just be points. Okay, so basically, make sure your lists are the same size and stuff. That means you're missing a number. And make sure these line up, because this will affect it. Zoom 9 for Zoom Stat. So then you can just copy it over from your calculator approximately. Do we get that? Alright, so now for the next part, what is the correlation between the percent of teens who have used marijuana and who have used other drugs? So we need to find the correlation coefficient, and at the moment, this isn't working like it's supposed to, so I have to go find what we have to do to get that. What? I'm trying to remember what I have to do to get... Because it was like turn the diagnostic on. I'm trying to remember how to do that so that it'll actually run everything to give me the R value. Hold on. Okay, so go on your calculator, hit mode. Okay, so we're going to turn the diagnostic on. Yeah, so if you arrow up, it'll be like the third one up from the bottom. I don't think so, but if it did, I'll try to check and make sure. I don't think it affects anything. I think it just basically makes your stat diagnostics do more. So some people were doing this before and they were like, why is mine doing this? Yeah, hit mode and then arrow till you see the word stat diagnostics. Yeah. Nine 11/2001. Oh, a rough day for that calculator. Mine is 1/2/01, so the time. You can set the time on your calculator. I realized mine's reset because I took the batteries out of it the other day. That means that's when your calculator was made. It'll always reset to that. If it dies, it'll always reset back to that. Alright, so once our stat diagnostics are on, now we should be able to second clit, stat, calc, linreg, okay, which is 4. Now in theory, this should do it. There we go. Alright. So hit, you don't have to, but yeah. So stat, calc, linreg, okay, and then it'll give you an R value. Okay, so in this case, R is equal to 0.93, okay, or approximately 0.93. Okay, so stat, calc, number 4, L1, L2, calculate. Did you make sure your diagnostic is on? On. Yeah, some people's were already on, so that's it. Okay, so that gives you your R values. That's how you get your correlation coefficient. Okay. So then the next thing says, write a brief description of the association. Okay, what are the 3 things we always want to talk about? The categories of things. Shape. Nope, not for these ones. Shape, strength, and direction. Okay, we always want to know those 3 things. When we're asked to describe something like this, we want to know shape, direction, and strength. I was about to say spread. I was like, that's not right. Alright, so what would we say about this one if it has a correlation coefficient of 0.93?
Hello.
Hi.
Melissa Burgess?
Yep.
Can you send her down?
Yes, I can.
Thank you, ma'am.
We're just going to finish these 2 and then we'll be done. Alright, so what would we say about the strength? Strong, positive. Linear. Okay, between the 2 different things. So between marijuana and other drug use, countries with higher percent marijuana use tend to have higher percentage of other drug use. And then lastly, do these results confirm that the marijuana is a gateway drug? That is, that marijuana use leads to the use of other drugs. Alyssa, I can send you a picture of these last two so you can write them down, because you're not really missing anything. I'm stopping the video after this. There's one on the floor. But do we know that marijuana causes you to do other drugs? No. Correlation does not mean causation. Okay? We can't prove using marijuana leads to other drugs. Bye, have a good trip. Bye.